Hey, hi all, once again welcome to Mathematics Mania YouTube channel. So in today's video we will see Lebnitz theorem and its proof. So what does Lebnitz theorem states is that if u and v are any two functions of x, then Lebnitz theorem states that the nth derivative of the product of these two functions u and v is given by d raised to n of u into v. That is, if u and v are two functions and their product, the nth derivative of their product is to be determined. So the Leibniz has given the theorem, he has given an expansion. So using the combinations expansion, so that is given by the nth derivative of u comma v will be equal to nc0 into dn of u. So let's call u and v, one as the first function and another as the second function. So what happens here is, in each and every term will start with nc0, nc1, nc2 and so on till ncn. So the first function we will be taking the nth derivative of the first function, and the first term will have the second function will start with just the function itself. So the second term nc1, so we will minus 1 from the first function and will have add 1 to the second function, which means to say here it is the nth derivative of u and the function v, nc1 n minus 1th derivative of the function u and first derivative of function v, and nc2 n minus 2th derivative of u and second derivative of v, and so on. So n minus 3rd derivative of the first function and third derivative of the second function, and so on. NCR, so for any arbitrary point r, so NCR d n minus rth derivative of u and rth derivative of v, and so on. The last term will be NCN, that is for nth derivative. So what happens in the nth derivative, the function u will remain as it is and the second function will be having the nth derivative of v. So if we see the first term and last term, NC0 is nothing but 1, so it will have the nth derivative of the first function and the second function will remain as it is, and the last term if we see ncn is again 1, and so the first function will remain as it is and d power n, I mean the nth derivative of v. So this is the expansion that is given by Leibniz for the nth derivative of differentiation. So this theorem can be proved using the principle of mathematical induction. So as we know that the principle of mathematical induction, how we prove is, we prove the result for n is equal to 1. The first time we will prove if n is equal to 1, then we assume that the result will be true for some arbitrary point n equal to m or n equal to k, something like that. And whenever we assume that the result is true for n equal to m, we will prove that the result is true for n is equal to m plus 1 also. So the principle of mathematical induction states that implies that whenever there is an m for which m plus 1 is also true, then that will hold good for all the values of m. So that way is, now let's prove that. Let's take the first derivative of this function. So what happens here, suppose u and v are two functions, so what happens here, if I am taking the first derivative of u and v, so let's apply the product rule here. So the product rule is, so that is the first function into derivative of the second function plus second function into derivative of the first function. So what happens, we can take either u and v as exchange like first or second function, whatever it is. So what I will do is, I am going to take the first derivative of u and I will write the v as it is. So now I will write u as it is into the derivative of v. So this is nothing but the derivative of u into second function plus u into derivative of the first function. So now what happens, I can write this as nc0 d1 of u into v plus nc1 u into d1 of v. So here n is 1, so 1c0 is 1 itself, so that will remain as d1 of u into v plus nc1 is again 1, that is 1c1 is again, here n is 1, so it will become 1c1 is again 1, so that will be u into d1 of v. So therefore the result is true for n is equal to 1. The result is true for n is equal to 1. So now let's assume the result is true for n is equal to some arbitrary point m. So what happens? So the Lebnitz theorem states that dn of u comma v is this one. So we have assumed that the result is true for n is equal to m. So that will be mth derivative of u comma v will be equal to so mc0 into mth derivative of the first function, that is dm of u into v plus mc1 dm minus 1 of u into d1 of v plus mc2 dm minus 2 of u into d2 of v plus and so on. We will write some middle term here, so that is mcr d m minus r the derivative of u into rth derivative of v, some arbitrary point, some arbitrary integer r. So and the last term will be, it will become mcm. So in the last term what happens? mcm, the first function will be the first function itself, so that is u into dmth derivative of v. Let's call it as equation number 1. So this is the result of Lebnitz theorem. So we have assumed that the result will be true for n is equal to m. So mth derivative of u comma v will be equal to this one. So now what we will do is differentiating equation number 1 with respect to x, both the sides. Let's differentiate both the sides of the equation by x with respect to x. So what happens? D by dx of d raised to m u comma v will be equal to, so the Lebnitz theorem states that this term is a completely, we have to take the derivative of this complete term, so that is d by dx of first term, d by dx of second term, we have to take the derivative of each term. So if d by dx of a plus b plus c, then we have to take d by dx of a plus d by dx of b plus d by dx of c. That is the basic rule of differentiation. So we will take d by dx of mc0 into d power m, not d power m, mth derivative of u into v plus d by dx of mc1 dm minus 1th derivative of u and first derivative of v plus d by dx of mc2 m minus 2th derivative of u into, let me write it here. So that will be plus d by dx of mc2, so m minus 2th derivative of u into second derivative of v plus and so on. We'll take some middle term, that is d by dx of mcr d minus m minus r derivative of u into rth derivative of v plus so on m d by dx of mcm into u into dmth derivative of v. Yeah, so now we will simplify it further. So d by dx of mth derivative of u comma v will become m plus 1th derivative of u comma v. So already we have the mth derivative of u comma v. So again we are differentiating with respect to x. So that will become d m plus 1th derivative of u comma v, that will be equal to, so mc0 is constant here, so let me take mc0 outside. So what happens, d by dx of this term I have to take. So I already have the mth derivative of u into v. So again I have to differentiate it one time. So I have to apply the product rule again here. So what happens here, so d by dx of, I have to apply the product rule here. So this will become d raised to m plus 1 of u into v plus d raised to m into d1 of v, right? Because see, if you see here, we had d raised to mth derivative of u into v, so we have to differentiate each term by with respect to x once again. So what happens, mth derivative is already there, so that will become m applying the product rule, derivative of dm of u will become d plus m1 of u into v, second function, plus first function into derivative of the second function, that is d1 of v. So in the same way, let's do for the other things also. So that will become mc1, let me take it outside. If I take mc1 outside, so this will be dm minus 1th term is there. So when I differentiate here, it will become mth derivative, right? So it will become dmth derivative of u into d1 of v, I will write as it is, d1 of v plus applying the product rule again. So this will become d raised to m minus 1 of u, into, so this will become d1 of u is there, now it will become d square v, d square v is nothing but second derivative of v. So in the same way, let's continue the simplification. That will be equal to mc2, I will take it outside, mc2 I am taking it out. When I am taking mc2 outside, so m minus 2 the derivative is there, this will become dm minus 1th derivative of u into second derivative of v plus dm minus 2th derivative of u into third derivative of v, right? And so on, d by dx of some middle term. So this will become mcr, I will take outside, mcr I am taking outside. So now this will become m minus rth derivative of u is there, now it will become d m minus r plus 1th derivative of u into dr of v plus d m minus rth derivative of u into r plus 1th derivative of v, right? And so on. Let's come to the last term, mcm. I will take the mcm outside. If I am taking mcm outside, so now u is there, the first function u simply is there. So now d by dx of u will become d1 of u into second function dm of v will remain as it is, plus now this u will be there as it is, u into d m plus 1th derivative of v. Yeah, so therefore let's again simplify this. So I have just written whatever I wrote in this page to here, just to it will be easy for me to see and write. So that let's simplify it here. So if you carefully observe here, so m plus 1th derivative of u comma v, see in each term if we see mc0 d m plus 1 of u into v, dm of u into d1 of v. In the second term if we see, we have the same terms here, mth derivative of u into first derivative of v mth derivative of u into first derivative of v. So each subsequent term, the second term of the previous term will be equal to the first term of the next term. So right, so mc0 and mc1, if you observe, d to the power of mth derivative of u into first derivative of v is there in this term also. And let's observe the same thing in mc1 and mc2. So the second term of this the second term of this mc1, if you see, m minus 1th derivative of u into second derivative of v is there. So the same thing is there here also, mc2, that is m minus 1th derivative of u into second derivative of v, and so on. So even here also, if we have taken only the 3 terms here, so this term will be equal to the first term of the fourth term. The same way, so what we can do here is we can take the common between each of these terms. So let me just take this mc0, mc1 and mc2, mcr inside, and I will take the common. So what happens? So that will be equal to d raised to m plus 1 of u comma v will be equal to the first term. This term will be independent because we do not have any previous term. So that will be mc0 m plus 1th derivative of u into the second function. So plus this term when I take, so mc0, in the mc0 term also it is there, in mc1 term also it is there. So what I will do is I will write mc0 plus mc1 into, I can write this one, that is d raised to mth derivative of u into first derivative of v, right, plus let me come to the next term. So I will take mc0 mc1 I wrote. So in these two also I have m minus 1 derivative of u and second derivative of v is common between mc1 and mc2. So what I will do is I will write the same thing here. So that will be mc1 plus mc2 of, so this will become d power m minus 1 u into second derivative of v. So plus the next term will become mc2 plus mc3. In the same way, this should become d power m minus 2th derivative of, so that is the third term, m minus 2th derivative of u into third derivative of v, yeah, and so on. Let me go to the middle term here, that is rth term. So when I am taking rth term, I will be taking mc r minus 1th term, that is one term before this term will be the r minus 1th term, right? So that term plus mcr into this will become d raised to m minus r plus 1th derivative of u into rth derivative of v. This will be rth derivative of v plus, and so on. I will be going to the last term. That last term is this one, mcm. So the last term is m here, so I will be taking the m minus 1th term. So that will become mc m minus 1 plus mc m minus m plus mcm. This will be into, so this we can write it as d1 of u. So whatever is there I am writing d1 of u into mth derivative of v plus the last term will be along with just with the mcm itself. It will not have any, just like the first term it had only the first term mc0 d raised to m plus 1 u into v. So the last term here will have, this will be plus, that will be equal to mcm into first function into m into the derivative of the second function. So that will be mcm into u into m plus 1 derivative of v, right? Yeah, so now so we will have to observe some properties here, that is from the basic properties of algebra. I would want to remind you that NCR plus NCR plus 1 can be written as N plus 1 C of R plus 1. This is the actually property of algebra. Whenever we have combination, NCR plus NCR plus 1 can be written as N plus 1 C of R plus 1. So what happens here in this term? MC0 plus MC1 can be written as M plus 1 C1. MC1 plus MC2 can be written as M plus 1 C2. MC2 plus MC3 can be written as M plus 1 C3, and so on. So we can replace this NCR into NCR plus 1 can be written as N plus 1 C into R plus 1. Also MC0 is nothing but 1. That is nothing but M plus 1 C0 also. MC0 is also equal to 1 and M plus 1 C0 is also equal to 1. So in place of MC0 I can write it as M plus 1 C0 because that will be having the same value 1. Also that will be equal to MCM, right? So NCN is nothing but 1. So that is also equal to M plus 1 C of M plus 1. So what happens? This time MC0 will become M plus 1 C0 because MC0 is equal to 1 and M plus 1 C0 is also equal to 1. So this MC0 can be written as M plus 1 C0. Also this last term MCM can be written as M plus 1 C M plus 1 because that also will be equal to 1 itself. So what happens? So we can write whatever the term we are taken here. So we can write it as M plus 1th derivative of u comma v can be written as, so what happens here, M plus 1 C0 d power of M plus 1 u into v plus M plus C1 into M plus C into d raised to M into u into d1 of v plus M plus 1 C2 as d power M minus 1 of u into second derivative of v and so on plus M plus 1 CR d M minus rth derivative of u into r. So rth derivative of v plus and so on, and we will write the last term here. So the last term will become M plus 1 C. So M plus 1 C of M plus 1 u into d power M plus 1 of v. We'll call it as equation number 2. And we had assumed something like n is equal to m of d of m is equation number 1. So we now have proved that d of m plus 1 also will follow the Leibnitz rule. So from 1 and 2, we can say that whenever the result is true for n is equal to m, the result is true for n is equal to m plus 1 also. Therefore the result follows the principle of mathematical induction, which means to say that so the Leibniz rule will be true for all the values of n for m. So hence the proof. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.